Good afternoon, class. In today's video, what I'd like to do is to go over another example in our gas laws example problems, and this one comes from Charles' law. And Charles' law states that V1 over T1 is equal to V2 over T2. So this, and by the way, this problem also comes from number 6 in the Charles' law review questions homework assignment. So just if you want to follow along from there. Now, the reason I picked number 6 and not like number 1 or any other one is because this one is a little bit more difficult mathematically, and that's why I wanted to tackle it, because the other ones are probably a little bit easier. I'm sure you can figure out how to work out all those problems using just your basic algebra skills. This one might require a few extra tips, so I thought I'd show you an example of how to do that one, and that's why I focused on this one today. So let's go over the given information in number 6, which is V1 is 2 cubic meters, T1 is, we don't know, so it's a question mark. V2 is 5 cubic meters, and T2 is 567 Kelvin. So in this case, what I'm going to do for this problem is I'm going to feature the shortcut method where I don't write in any of the units into this problem. The reason for that is twofold. One, I want you to get comfortable with the shortcut method and just seeing it presented on video. And the second reason is because this video is going to be a little bit more mathematically technical. So I wanted to focus on the math more than the units. So here we go. I'm plugging, all I'm doing is substituting the given values and solving. So 2 over T1 is equal to 5 over 567. That's great. So now what I'm going to do is I'm going to isolate the variable. In order to isolate the variable, I need to do the opposite operation that's being done to the variable that I want to isolate. Now in this case, see, you have to understand, in this case, T1 is in the denominator. So now there are several ways I could do this. One, I could just take this equation, this fraction right here, and just flip it, and do the same thing, of course, to the other side, and things would be a whole lot simpler. But I thought I'd show the actual process of me just going through and flipping or inverting the fraction, if you will. So that's why I said I'd kind of break this down, try to do this as step by step as possible. Do you have to do all of these steps to solve this problem? No, you don't. It's not necessary. There are several actual methods. But what I thought I'd do is pick the most thorough method to show you how to solve this problem, so that if you have any other tips and tricks in your mathematical toolbox that your math teachers have given you, you could use those. So in this case, what I do is I look at this and I'm saying I'm going to isolate this T1, but in order to do that, I got to get rid of this 2. So in order to get rid of this 2, I need to do the opposite operation that's being done to it, or I need to divide it out and get 1. So because 2 is in the numerator, I'm going to multiply it by 1/2, which is the opposite of 2, or at least it will give me the value of 1 that I'm looking for. The other reason I didn't use just division in here is because, and rather I chose to multiply by the inverse of that number, and the reason I did that is because I wanted to, if I put a 2 over here and I divide it by this, then that could work, but putting it on the other side of the equation would be a little bit more difficult, at least to justify, because sometimes, in this case it might work out, but order matters when you're doing division problems, so I don't want to ever get that confused. Usually if I want to do something, I'll do multiplication instead. That way at least I won't have to worry about order, because order does matter when it comes to division and subtraction. Okay, let's move on. So 2 divided by 2 is 1, and then all I do is I just multiply this fraction through. Now, what I could do is convert all of these to decimals and then do all of my calculations from there. But this time what I thought I'd do is to keep them as fractions, not because necessarily decimals are bad. It's just that fractions are a little bit cleaner, at least to figure out what is what. Because in this case, as long as you're okay with this fraction bar, you're dealing with whole numbers right here. Because right now I'm got 5 times 1 divided by 567 times 2. And while that 567 times 2 is not very fun, at least it's whole numbers instead of some very small number times 0.5. You know, that's how I look at it. And of course, that's just my personal preference. Maybe you like using decimals like this. That's fine. Feel free to use any method that works for you. This is the one that I find to be at least the one that is able to help me track any mistakes that I make, and it allows me to see what step I took from one step to another. So that's what I'm doing here. So in this case, I've now got 1 over t1 is equal to 5 over 1,134. Okay, so far so good. However, I do want that t1 in the numerator. And now I know what you're also thinking. Well, couldn't you just take this fraction, flip it, this fraction, and flip it, and you would have your answer? And the answer is, of course I could. But I wanted to show that actual process of that, that inversion. So because if I didn't, you would just think, oh, I could just flip something and then it'd be fine. That's not actually how it works. There is actually a process for how this goes, and that's what I'm trying to show you right here. So what I do is I multiply both sides, because right now this t1 is in the denominator. To get it to the numerator, I have to multiply both sides of the equation by t1 in order so that t1 cancels on the left side and is now in the numerator on the right side of the equation. So that's why, and because t1 over t1 is 1, so that way this gets eliminated. So t1 divided by t1 is 1, so that's why I have a 1 here. Now I've got 5 over 1,134 times t1. So in this case, now we're finally back to what we did in the other videos that I made, where I'm trying to isolate this variable over here, this t1 variable. So I'm going to isolate the variable. To isolate the variable, I need to do the opposite operation that's being done to it. So in this case, it's being multiplied by 5 over 1,134. So I then multiply it, or I then do the opposite operation, which is division, but because I don't want to do division necessarily, because of the fact that order does matter, what I'll do is I'll multiply instead by the inverse. So in this case, I've got the inverse is 1,134 over 5. So I multiply both sides of the equation by this number, and then I get my answer of t1 equals 1,134 over 5 Kelvin. Now I know some teachers will be out there that say, hey, you have to put that in decimal form. I'm not like that. If this is your answer and you write this on the test, this is great. I love this answer. So don't ever feel like, in my class at least, that you have to say, I have to change this to decimals. I have to worry about scientific notation. You do have to worry about scientific notation if this is in a decimal form. But if it's in a fractional form, that's fine. Just leave it as a fraction. Scientific notation is actually taken care of simply by the fact that this is in a fractional form. So thought I'd go into that a little bit. Yes, this is a very technical process of how to do this. I could probably do this problem multiple ways, over the course of many different videos. But for this one, I wanted to leave it just this way, because there are some simpler ways of doing this, but I wanted to show the complex way. But it is also very complete, because you can look from here all the way to here and then track back all of the work that I've done. And that's actually important if you want to be able to actually figure out what your errors are. This would be the way to do that. If you just want to get through the problems as quickly as possible because you know all of this already, then there are other shorter methods for you to use. So I thought I would go over this one, especially because that t1, or the variable that we want, is in the denominator, and dealing with that is actually going to be a very important thing. It doesn't matter if this was t1 you're solving for, or t2 that you're solving for. Anytime something's in your variable is in the denominator, you kind of need to do something like this in order to get your variable that you want in the numerator. And because that's the only way that you're actually going to be able to solve this. So with that, I thought I'd leave it at that, and we'll move on to the next video in our series when we talk about the next of the gas laws. But for now, that concludes this video on Charles' law. Good luck in your studies, and may the force be with you.